Now we will go to a young researcher, Claudia Caporizzo from University of Naples, Parthenope in Italy. She will present us reconstructing Roman landscapes in the underwater sector of a Campi Flegrei volcanic area, a multi-survey approach. Claudia Caporizzo, the floor is yours.
Thank you very much. I hope you can see the presentation in the full screen.
Yes, we can.
Okay, so first of all, I would like to say that I'm really happy to be here and having the chance to present my research as a young geomorphologist. So I really would like to thank you all the organizers for inviting me. And as already said, I'm from the University of Naples, Parthenope in Italy, and I'm a PhD candidate. And the work that I will show you today represents an integral part of my PhD project. But before moving to the presentation, it is really important for me to introduce you the research group of which I am part, which also includes Professor Gerardo Pappone, Professor Petrocelli, Professor Aldo Cinque, Dr. Gaia Mattei, and our technical staff, including Francesco Peluso and Luigi De Luca. The present research has been conducted into the Campi Flegrei volcanic area. There is one of the most dangerous and sensitive zones of the Mediterranean region. Volcanic areas are well known for being affected by sudden vertical ground movement, and Campi Flegrei in particular during the Holocene was affected by this phenomena called bradyseismic crisis, which have led to strong variations of the coastal landscape. The Campi Flegrei area is a magnificent case where traces of human adaptation to volcanic events have been visible since its colonization. The great urbanization of the area happened during the Roman time with the construction of an almost uninterrupted sequence of seaside luxurious villas. Since the reconstruction of the vertical ground movements of volcanic origin registered in the area during the Roman time is still unclear, the aim of this study is to reconstruct the morphoevolution of this coastal sector between the 1st century BC and the 2nd century AD, focusing on the reconstruction of the relative sea level variations of volcanotectonic origin and the quantification of the related vertical displacements. The research underlines the effectiveness of a multi-survey approach in both the determination of past relative sea levels and the reconstruction of onshore coastal landscape morphologies. The first methodological differentiation can be made by distinguishing between direct and indirect underwater surveys. In particular, the indirect surveys carried out in this work were constituted by morphoacoustic side-scan sonar surveys and optical photogrammetric reconstructions. On the other hand, numerous direct underwater surveys were carried out along the whole Campi Flegrei coastal sector in order to calculate the submersion measurements of particular archaeological features interpreted as indicators of past sea level positions. Moreover, in order to avoid data misinterpretation, the direct and indirect underwater surveys were always associated with extensive geological and geomorphological on-field analysis of the emerged sector and, when needed, archaeological consultancy as well. We interpreted as sea level index points those structures which are clearly related to the former mean sea level, and in particular, for every sea level marker, we considered a specific value of functional clearance based on archaeological interpretation, defined as a specific minimum elevation of each structure above the former sea level. And for every sea level marker, we considered a value of the indicative range, intended as the elevation range over which the marker form referred to a tidal level. In the study area, 3 different types of archaeological sea level markers were detected: fish tanks, coastal defense structures, and in particular the Roman pile, and building remains. While in the case of the fish tank, the top of the sluice gate, that was the gate of the tank, was intended as sea level index points, In the case of the coastal defense structures, they can be used as sea level index points by detecting the submersion measurements of the concrete change. The concrete change is the limit between the areas of the structure built in hydraulic concrete and the areas of the structure built with concrete totally laid in a subaerial environment. Even if the archaeological ruins as pavement remains of basalt floors didn't have a direct connection with the coeval sea level, they can still be interpreted as terrestrial limiting points, helping in the positioning of an upper maximum limit for the past sea level position. As we know, the local relative sea level changes are primarily affected by glacial and hydroisostatic adjustment, and the GIA relative sea level changes are described by the sea level equation. In this research, thanks to the work carried out with Dr. Paolo Stocchi from the Department of Coastal System of the Royal Netherlands Institute for Sea Research, a suite of relative sea level curves was produced by using the sea level equation solver Selene, coupled to 3 different ice sheet models. The sea level equation has been solved for a total of 54 models, assuming 3 values of lithosphere thicknesses and considering 3 ranges of value for the intermediate and middle mantle viscosity. Then the vertical displacement related to every sea level marker was calculated through the use of a Bayesian statistical approach, together with the calculation of the related subsidence or uplift rates. Let's move on to the description and characterization of the main investigated archaeological sites. The first one is the archaeological site of Portus Iulius, that during the Roman period experienced at least 2 different constructional phases. The first one was a brief military phase, started at the year 37 before Christ, with the construction of the main entry channel and the pile located at its entrance. The second was a longer commercial phase, started at about the year 12 before Christ, when the area was completely renovated and equipped with the construction of several warehouses and the fish tank system. In the first instance, the survey involved some pavement remains of a basal floor, interpreted as terrestrial limiting points, and related to an ancient maritime villa during the first half of the 1st century before Christ, before the construction of the harbor. Nowadays, these floors remains are located at about 3 meters of depth. Then the submersion of the top of the sluice gate and the concrete change of the pillar was measured, and the relative sea level of minus 3.1 meters below the medium sea level was detected for the time span between the year 37 and the year 12 before Christ. Moreover, in this case, a photogrammetric reconstruction of the fish tank was realized in order to better characterize its structural features. The remains of the Pisoni Villa are located to the southeast of Punta Epitaffio and dated at the end of the 1st century AD. During the diving inspection carried out at these sites, the top of the sluice gate of the fish tank was measured, resulting in a relative sea level of about minus 7 meters below the medium sea level. Moreover, the remains of a nymphaeum attributed to the Emperor Claudius are located a little further north and consequently dated to the first half of the 1st century AD. The direct surveys carried out in this site provided the submersion measurements of a perfectly preserved marble floor, interpreted as terrestrial limiting point and located at a depth of about minus 4.8 meters below the medium sea level. The remains of another maritime villa are located southwest of Pisoni Villa and dated at the end of the 1st century AD. The direct surveys carried out in these sites, conventionally referred to as Protiro Villa, aimed at measured the submersion of 2 beautiful and perfectly preserved mosaic floors interpreted as terrestrial limiting points and nowadays located at a depth between minus 4.5 and minus 4.7 meters below the median sea level. Moreover, in order to provide a better characterization of the villa and a detailed planar reconstruction of the submerged structures, a side-scan sonar survey was carried out. At the fish tank located near the Aragonese castle of Baia, a morphoacoustic survey provided a detailed planar reconstruction of the submerged archaeological structure and a characterization of the underwater landscape. Instead, the submersion measurements of the top of the best preserved sluice gate was obtained from the direct survey of the fish tank, allowing the determination of a relative sea level located at minus 4.2 meters below the median sea level, deduced for the time span between the year 60 and the year 34 before Christ, considering that the fish tank is interpreted as a part of Caesar domains in Baia. Moving southward, a series of direct surveys concerned the fish tanks located at Marina Grande di Bacoli and at Miseno Cape, precisely at Punta Perone. During the diving inspection carried out at the first fish tank in Bacoli, belonged to the Roman orator and politician Hortensius Ortalos and consequently dated between the years 70 and 50 before Christ, the submersion of the top of the perfectly preserved sluice gate was measured and the relative sea level at minus 4 meters below the median sea level was deduced for the half of the 1st century before Christ. The same thing was done for the second fish tank, related this time to a maritime villa, probably built before the relocation of the military fleet within the Misenum Bay, but surely used until the 12th before Christ. Here, the position of the top of the sluice gate was detected and the related relative sea level for the half of the 1st century before Christ was calculated at minus 4.2 meters below the median sea level. The complex of fish tanks located next to the Dragonara Cave along the northwest side of Miseno Cape represents the only investigated archaeological sites located along the external margin of the Campi Flegrei caldera. These structures were historically attributed to the Roman politician Lucullus and consequently dated at the year 60 before Christ. During the direct surveys carried out in these sites, the lowest level of crepito was detected, allowing the determination of a relative sea level at minus 3.2 meters below the median sea level for the half of the 1st century before Christ. On the map present in these slides, all the surveyed Roman archaeological sites are represented in a different color based on their age, together with the related relative sea level measurements and the type of used sea level marker, distinguishing between sea level index points and terrestrial limiting points. This multi-technique approach and the high temporal and spatial precision of the survey data allowed obtaining high-resolution paleolandscape reconstruction of the Campi Flegrei caldera during different ages related to the Roman period, and of course, the evolution of the area in terms of vertical ground movements of volcanic origin. In particular, the relative sea level at the beginning of the 1st century before Christ was positioned at about minus 8 meters below the median sea level, as highlighted by some intertidal deposits found within a core performed in Baia and corroborated by a series of terrestrial limiting points of the same age and represented in red in the map. Later, probably due to a subsidence of volcanotectonic origin, highlighted in the graph on the left by the area in red, the sea level quickly raised, reaching the level of minus 4 meters below the median sea level by the 1st half of the 1st century before Christ, as measured by the fish tank from the fish tank located along the Baia Miseno coastal sector, and continuing to increase up to minus 3.1 meters in the year 37 before Christ, as measured from the pile located at Portus Iulius. At this stage, the relative sea level probably lived a period of volcanotectonic stability, highlighted with the area in light blue in the graph, that lasted until the beginning of the 1st century AD, as testified from the measurements carried out at the fish tank of Portus Julius. Finally, the area was affected by a new uplift, represented by the green area in the graph, which caused a relative sea level drop up to almost -7 meters below the median sea level at the end of the 1st century AD, as testified by the measurements taken from the fish tank located at the Pisoni Villa and corroborated by numerous terrestrial limiting points of the same age and represented in the map in green. In conclusion, by comparing the data coming from the fish tanks located along the Baia Miseno coastal sector, dated at the half of the 1st century before Christ, with the data coming from the fish tanks located next to the Dragonara cave, always ascribable to the half of the 1st century before Christ, but located along the external margin of the Campi Flegrei caldera, it is possible to notice for the same age a differential behavior in terms of relative sea level variation. And that's why the following step of this study is going to collect more data coming from additional sites located along the external calderic border in order to better clarify this particular aspect. The presented research falls within the discussion carried out in the framework of the Neptune Inqua project. Neptune is born under the umbrella of the Inqua Commission for Coastal and Marine Processes, taken up by the President Sarah Woodruff from the University of Durham, the Secretary Rob Barnett from the University of Exeter, and the Vice Presidents Matteo Vacchi from the University of Pisa and Nicole Khan from the University of Hong Kong. I am pleased to be one of the Neptune project leaders, together with Gaia Mattei from the University of Naples Parthenope, Anna Novak from the University of Ljubljana, Livio Ronchi from the University of Padova, and Martin Sidiger from the Goethe University of Frankfurt. The aim of the Neptune project is the creation of an interdisciplinary working group of young scientists aimed to develop multidisciplinary techniques to analyze and reconstruct the past landscape, nowadays submerged due to the post-glacial sea level rise. With this project, we want to create a new platform to establish interdisciplinary trans-Mediterranean collaborations between experts in archaeology, geomorphology, and marine surveying, in order to provide an optimal integration among geological, archaeological, and modeling methods. The Neptune project started on 30 March in 2020 with an online meeting of the leaders, and in order to react to the pandemic emergency due to COVID-19, we decided to organize the first meeting of the Neptune community online. The meeting took place on September 3rd and was titled Reconstructing Underwater Landscapes by Marine Surveys, and it was divided into parts. The first part was dedicated to oral presentations of young early career researchers and PhD students, and the second part was focused on the open issues faced by the researchers during their activity. Actually, we have several scientific activities already planned for the next months, which includes the organization of a dedicated EGU session that will be held online on April 28, titled Underwater Paleolandscape Reconstruction by Using Multiproxy Approach in the Framework of the Inqua Project, and the next opening of a special issue in Quaternary International titled Lost Landscapes, Reconstructing the Evolution of Coastal Areas since the Late Pleistocene. Moreover, together with the Splosh Inqua Focus Group, we are planning another online event that will take place in June, titled Shine, Sparkling Light Once Again Over Landscapes Overshadowed by Time. And with Shine in particular, we want to provide a non-traditional workshop where participants are invited to present their field activities and their study areas as an ideal worldwide virtual scientific tour. The deadline for the abstract submission for the Shine is April 30, and when the pandemic crisis will be over, we are hopefully planning to organize 4 face-to-face meetings. The first one will be held in Naples, the second one in Frankfurt, the third between the Venice Lagoon and Padova, and the fourth between Ljubljana and Trieste. I would like to conclude saying that if you are interested in the Neptune project and you want to join our Neptune community, you can read more about us and our activity on the last two numbers of the Inqua newsletters, Quaternary Perspectives, or you can find more info on our website and following our activities on our social media channels. Thank you very much.
Thank you, Claudia Caporizzo, for this very nice presentation and for inviting this team to those interesting activities you have already organized. I'm sure that my team will be there and we will be delighted to do that.
Thank you very much.
Thank you. And let me check if I don't see if any questions in the chat, but maybe somebody would like to ask something. You may, if you wish so, to appoint a question to Claudia Caporizzo, you may activate your microphone. Okay, I have a question for you, Claudia. First of all, I found very interesting what you are doing, and I would like to ask you, in your work, you presented new GIA models produced for the study area. Why didn't you use already existing GIA models, and did you notice any problems in quantification between different models? Why you didn't use the already existed?
Okay, so thank you very much for the question. First of all, the creation of new GIA models for the study area was motivated by the fact that there were not GIA models available precisely for the Gulf of Naples. And until now, the relative sea level measurements were always compared to GIA models produced for the surrounding areas. Moreover, during my PhD, I had the chance to spend a stage 1 month at the Royal Netherlands Institute for Sea Research in the Dutch island of Texel, working with Dr. Paolo Stocchi. And there I had the chance to learn a lot more about the GIA processes and to learn a procedure to calculate the vertical displacement based of a Bayesian statistical approach implying Monte Carlo simulation. That was really the major difference, made the difference in my work. And answering the second question, comparing the results in terms of vertical ground movements obtained from our models with the other GIA models available for the surrounding areas, we noticed that before, the values of the local volcanotectonic subsidence were lower if compared to the values of vertical displacement obtained by using our statistical procedure. So I hope I answered fully to your question.
Thank you very much. It's interesting that you have combined these fields and you are also engaged with the GIA modeling. We know it's not an easy task. Yeah. And I have one more question. Which might be the fallout from your research on the future management of this coastal area?
Okay. It's really important to know, in a context really complex as the Flegreian one, the past behavior of the area in terms of vertical ground movements of volcanotectonic origin, because this can help in a better zonation of the different sectors of the caldera based on their response to the local geodynamics. And this, in association with other specific studies, can lead to a better definition of the phenomena that characterize the Campi Flegrei area. And indeed, as we know, we can say that, of course, it's always fundamental to know the past behavior of an area in order to better understand the future.
Okay, thank you very much. If nobody else would like to ask something, then we may shift to the next presentation. Thank you, Claudia Caporizzo, for
Thank you very
this
much for everything and
very
for the
interesting, yeah. And congratulations to the whole team for what you're doing.
Thank you.